Hello everyone. In this lesson, we will find the equations of a tangent line and a normal line of a curve. And the curve is given to us as y squared plus 5 times xy equal to negative 21. And we are given a point at 2 and negative 3. So if you take a look at this function, you will see that there's no way that you can just isolate the y and then you can just find dy over dx. So in this case, you see that in order for you to find dy over dx, you will have to differentiate implicitly, and we go over the concept of solving for dy over dx in the process of differentiating implicitly. Alright, and this question is straightforward. We find the equation of tangent line, normal line, and we are given a point. Right? So we're given a point to work with. So what you need to do is you have to find the slope. And then after you find the slope, you can substitute this point into the equation as we mentioned earlier. So a reminder for everyone that y minus y1 equal to n multiplied by x minus x1. So before I get started, I just want to summarize the formulas and the process of what we need to apply when we work for questions like this. Okay, we work to solve for a question like that. Alright, so the first thing we want to remember is the equation y minus y1 equal to m x minus x1. Okay, so this is called the point slope form. So this is called the point slope form. So if you have a slope and a point, then you can go ahead and apply to this equation. So where does this coming from? This one is in fact coming from. Okay, so hint for this is if I write the slope y minus y1 divided by x minus x1, then is equal to the slope. So the slope is always equal to the difference in y divided by the difference in x, right? So it's very much similar to this. You can find it written like that. And then you see that if I multiply this part over to the other side of the equation, I got the point slope form. So you are using this equation when you have a point and a slope to work with. Okay, so if you want to find the slope, the easiest is to get to this equation y equal to mx plus b. So it's so easy to point to get the slope out from here as a coefficient of x, and make sure that you solve for y completely on this side of the equation. So what is the idea of the slope? The slope is in fact, so if you take a look at this, what I wrote, I can always write it like this. Okay, so the difference in y divided by difference in x will be equal to the slope. So if you find dy over dx, so this one is the derivative of a function y with respect to x. Okay, so derivative of function y with respect to x, if you are finding this and if you are given a value for x, okay, so x equal to a value, okay, then you can find the m, and that is the slope of the line tangent to the curve at that given point. Okay, so this is the slope of the line tangent to the curve. Okay, so you can find the actual value of the slope by having the x value substitute in here. Then you can find the slope, the actual value to the slope. But most of the time, they are asking us to find it in general form. So I want to write it a linear function or a straight line. then I should have the equation A, okay, x plus b y plus c and is equal to 0. Okay, so where a, b, c are integer, and we all remember the definition of integers, right? It's a whole number, but you have positive and negative sign attached to it. A, B, C cannot be a decimal or a fraction. You need to have them as integers. Okay, so that's the summary of what we need to do, right? So when we ask to find the equation of a straight line, immediately you want to find the slope and you want to have a point to work with. So where does this equation coming from? It's actually coming from the equation for the slope. Difference in y divided by the difference in x, or rise over run. And this can be translated into the idea of derivative for the tangent. So that means dy over dx is the slope. What is that slope? The slope of a line tangent to the curve will be our derivative. Okay, so I thought I mentioned this to everyone before I continue with our example. So again, right, you are given a point. So what you do is you immediately think of this equation. Okay, so I have to find the equation of this tangent line and this normal line. So I have to think of this equation right away, and a point is given to us. And what is the mt versus the m normal? Okay, the slope. So if you take the value for the slope of the tangent, you divide into -1, you can find the value for the normal, okay? The slope for the normal. So it's vice versa here. So they are perpendicular to each other, so they are negative reciprocal of one and the other. So equations in general form again. Okay, so I didn't mention it here, but I believe that I asked everyone to put it in general form. Then what we need to do is we still have to remember the general form is ax plus by, ax plus by plus c, and then equal to 0. All right? Okay. So I think everyone remember this at this point. So maybe I should just write ax plus by plus c equal to 0 in general form. And we have to differentiate this implicitly. Alright, okay, so the point given to us is 2 and 3, so let me point that out for everyone. So here is 2 and -3, I mean -3, I'm sorry. So x equal to 2, y equal to -3, which is here. So if we click on that, that is the exact point right there. Alright, so then we are talking about this part of the graph. So this part of the graph will work like that. So let me try it one more time, try to trace this. So this graph, it looks like this. Right, okay, and the line that we are talking about is this is the tangent. Okay, and the normal is the one that perpendicular to this tangent. Don't forget, it's only perpendicular to the tangent, then they become a normal. But if you have any line perpendicular to this tangent, but it's not at this point, then it's not a normal. Okay, a normal is the definition for the normal is a normal is perpendicular to the tangent line, and tangent only touches this curve at only one point. So that's the characteristic of the tangent and the normal. Okay, so let's differentiate this implicitly. So let me rewrite y squared plus 5xy equal to -21. Okay, differentiate this implicitly means that I will immediately write d of y squared as a function of x. Okay, you may find that this is the tedious step. You don't want to write this. However, I always do this to remind myself that differentiate implicitly, I need to differentiate everything with respect to x. Even I have the x, I also have to write differentiate with respect to x. Then in here you can see that you are going to find derivative of y squared. Derivative of y squared will be 2y, but immediately after you need to write dy over dx. You multiply by dy over dx in this case, because in the way that you apply the chain rule for this particular differentiation, you differentiate y in terms of x, you must multiply by derivative of y as a function of x. So don't miss this variable. Okay, so but this part, what I have is I want to differentiate this on the side. Why I'm doing that is because it is a product rule. You are multiplying 5x with y and you differentiate in terms of x, so it is a product rule. Okay, so when we differentiate in terms of product rule, I will do it on the side and I will write it into this line. Okay, so I will have to differentiate 5xy as a function of x. Okay, reminder, this one is the product rule. Okay, so differentiate this as product rule. What do I have? I am having this as let me see, I do have plenty of space, so let me just differentiate it on another page, because then I will have more room. Alright, so pardon me everyone, I just want to rewrite it here. 5xy divided by dx. This one is the product rule. Okay, product rule. Then what is the equation to find the product rule? For the product rule, so that means d of u times v as a function of x will be u times dv over dx plus v times du over dx. So here is the formulas for the product rule. It means that this one, you are going to identify which one is u and which one is v. So I recommend that you keep the phi with the x and identify u as 5x. Okay, so now don't forget du over dx. What is the derivative of 5x in terms of x, which is 5, but time dx over dx. And you know that dx over dx will cancel out, so therefore du over dx in this case is just equal to 5. Then the next step is v is equal to y, right? So then dv over dx, that means you differentiate in terms of y, so 1 times dy over dx. So derivative of y is 1, but you differentiate in terms of with respect to x, so you must multiply by dy over dx. Alright, so now you have u, you have v, you have du over dx, you have dv over dx. You can go ahead and substitute into this equation. So in this equation, then I end up with the value as u, which is 5. Okay, so derivative of 5xy in terms of x will give me u as 5x. Okay, then I multiply by dv over dx, so I multiply by dy over dx. And then I add that with v, which is y, and I multiply by du over dx, which is 5. So this is what I have to do on the side, because I want to present this one as a product rule. So then let's substitute this into what we have up here. Okay, so what I'm going to do is I am going to rewrite this, okay, on the next page, so we have some consistency here. So I will write it as, therefore, okay, I will have 2y times dy over dx, and then I add that with this whole thing. Okay, so that's 5x times dy over dx. I will put this in the bracket now. And plus 5y equal to, what is the derivative of negative 21 as a function of x? Is equal to 0. Okay, so let me go back and show everyone. Okay, so this one I can write 2y dy over dx. Okay, so this one I could put c below on the next page. But for this one, I will tell you that derivative of negative 21 is 0, and then times dx over dx. So this is very important, and I really want to show everyone that you need to really understand that differentiate implicitly. You need to involve all the notation, the behind the scene of all of this notation. If you forget, you may want to go back and review the lesson for differentiate implicitly. I explain into details the notation beside all of this. Okay, so just to make sure that my note is consistent, because I post a note for everyone later on. And there it is that we have. So we need to differentiate. Yeah, we did differentiate it already, but we need to solve for this dy over dx. So now I am going to choose the common factor. So isn't this my common factor? So I put dy over dx, I pulled it out of the bracket. Inside the bracket, I should have 2y plus 5x, right? At the same time, I am going to move this one over to the other side of the equation. So I have negative 5y. So now you see your dy over dx is equal to negative 5y divided by 2y plus 5x. Alright, okay? So you are having the differential equation dy over dx equal to negative 5y over 2y plus 5x. At this point, a point is given to you, and that point is given to us as at x equal to 2 and y is equal to negative 3. So obviously, you are going to take these two values and substitute into this equation in order to solve for your dy over dx, right? So I am going to write this notation as dy over dx, evaluate as 2 and negative 3, then I should have negative 5 times the negative 2, I mean negative 3, okay, I'm sorry, negative 3, divided by 2 times negative 3, and plus 5 times 2. Okay, so just want to double check. Y and Y, Y with Y, X and X. Okay, so we do this calculation. We have dy over dx will be equal to 15 over negative 6 plus 10, so it's 4. So in this case, it's equal to the slope of the tangent line. Alright, okay. So that means we are going to figure out the equation for the tangent using this empty, and also using the point 2 and negative 3, right? At 2 and negative 3. Okay, so you may want to see this here, mt will be equal to 15 over 4. Okay, for your normal, okay, m of normal will be equal to negative 1 divided by 15 over 4. So you should have is equal to negative 4 over 15. So the slope of the normal will be negative 4 over 15, and the slope of the tangent will be 15 over 4, because it's negative reciprocal of one to the other. Okay, so then all we have to do now is just substitute the slope and the point into our equation of point slope form to figure out the equation for the tangent and the equation for the normal. Okay, so the equation for the tangent is Okay, so let's work with this. I have to give myself some room. I don't think I give myself enough room. Okay, so that's giving me, I will divide this space that I have into two. Okay, so right here I will say the equation for the tangent is, okay, so on this part of the graph, this part of the paper, I will work on the tangent. So I will have y minus y1 equal to nt times x minus x1. So I should have y minus of minus 3 multiplied by 15 over 4 times x minus 2. So you see I will multiply 4 over to the side. Okay, so 4 multiplied by y plus 3 equal to 15 x minus 2. You see that that negative times that negative will be a plus, and if I bring 4 over to multiply by this whole here, I have to multiply by the whole binomials. Okay, that's how you can get rid of your denominator in just one step. Okay, so now I'm going to distribute. So I have 4y plus 12 equal to 15x subtract 30. So I'm going to move everything over to one side of the equation. So I will let this equal to 0, and I will bring the y over. In this case, you see that I try to avoid the negative in front of x here. Okay, but it actually doesn't matter. So 15x minus 4y subtract 42 equal to 0. So this is the equation for the tangent. And here is my A, here is my B, here is my C. Okay, so A equal to 15, B equal to negative 4, C equal to negative 42. And they are integers, right? They are integer. So this one is in general form. Alright, okay, so let's move on to our equation for the normal. So I just have to go through this process one more time. Okay, so want to make sure that we work with the normal, and here to work with the tangent. So we're going to use the mn in this case. So y minus y1 equal to mn multiplied by x minus x1. So I will have y minus minus 3 equal to negative 4 over 15 of x minus 2. Okay. Okay, so now I'm going to bring the 15 over, multiply by, so 15 multiplied by y plus 3 equal to negative 4 times x minus 2. Okay, so bring this 15 over and multiply by this side of the equation. You make sure that you multiply by the entire binomial, then you can get rid of your denominator all at once. Okay, so I will distribute the term 15y plus 45 equal to negative 4x plus 8, and I will have, now I will move 4x over to the side, equal to 0. So combine these two. Here I also want to say that to everyone here. 4x plus 15y plus 37 equal to 0. So this is the equation for the normal. And we are having, this one is A, this one is B, and this one is C. So this one equal to 4, 15, and 37. Okay, and they are in general form, where 4, 15, 37s are integers. Alright, so let me kind of recap what we're supposed to do. because I still have a few more minutes left. Okay, so basically, um, one of the very important application of derivatives is understanding what derivative is all about in terms of finding the derivative. What is dy over dx? Um, what do we want to achieve when we differentiate a function? Okay, so when we differentiate a function, that means we find dy over dx, the change in y divided by the change in x, in the way that we are finding the slope. But what slope is that? It's the slope of the line tangent to that function at a given point. So what is a tangent line? Tangent line is a line that touches that function at only one point. So at that only one point, if you have a line that called normal, that means that line is perpendicular to the tangent line. So the normal line and the tangent line, they share the same point. Okay, so this point is only one point that this line touches it, and then at this point there's a line perpendicular to it, so that's called the normal, and that is called the tangent. So in order for us to determine the equation of these two tangent and this normal, what we need to do is we need to have a slope and a point. So a slope, if we find the slope of the tangent, that means you differentiate, you find the slope, then you apply the idea of negative reciprocal to get the slope of the normal. And if you have a point to work with, then you can go ahead and substitute into this equation right here. So it's more like a reminder for everyone. Okay, so if you go back to the previous page that I put here, you can see that it is a summary. Okay, so this is a summary. The process of what you need to do in terms of finding the equation of a tangent line or a normal line. Okay, so this function given to us in the form that we cannot solve for y, so we have no choice, but we have to differentiate implicitly. And differentiate implicitly, we will just starting with the process of we differentiate each term with respect to x, and where you found the product rule, I would do it separately so that I can substitute that into the equation properly, because I don't want to miss anything here. Alright, okay, because you don't want to miss the dy over dx, which is actually very important, because you have to factor and solve for it after. And after you find dy over dx, given the point of both x and y, you substitute into this differential equation, you find the value for this dy over dx, which is also your slope of the tangent. And then since tangent and normal are perpendicular to each other, you can take the negative reciprocal to get the slope of the normal. And after you get the slope of the normal, you can find its equation. Okay, you get the slope of the tangent, you can find its equation. And don't forget, rearrange, manipulate using your algebra to write the equation in general form. Okay, so let me write in here to complete our diagram the equation that we found. Okay, so the tangent is 15x. Subtract 4y, subtract 42 equal to 0. So this is my tangent. Okay, and for my normal, I have 4x plus 15y plus 37 equal to 0. Alright, thank you everyone.